Hey everyone! In the last video we covered everything about vectors. Now, it's time to put that knowledge to the test. In this video, we'll solve exam-style vector questions step by step, covering vector addition, magnitude, and much more. Starting off, we have this question. Find C for given chords of A, B, and D. We have been given that ABCD is a parallelogram, therefore AB and DC must be parallel. In the previous video, we learned that parallel vectors have the same ratio. We'll save this info for later. We can write AB equals OB minus OA, as we learned in the previous video. O is the origin, so vectors OA and OB are equal to points A and B, respectively. Write them as column vectors and subtract to get vector AB. Same goes for vector DC. We don't have point C, so we can write X and Y in its place. As we know that AB and DC are parallel, their ratio must be same. We can find the missing X and Y by equating their ratios. This gives C equals 9, 11. Next question, OACB is a quadrilateral. OA equals A, OB equals B, and AC equals 2B. D is the point on BC such that BD ratio BC equals 1 ratio 3. Part A asks us to find vector OC, highlighted in yellow. For these type of questions, we have to find a known path for the vector we have to find. One way to do this is to go from O to A and then A to C. This is the only solution because we have been given the vectors OA and AC. Therefore, we can write the equation OC equals OA plus AC. Then fill the known values for OA and AC, which gives us the required value for OC, which is A plus 2B. The next part asks us to find BC. This is very similar to part A. BC equals BO plus OC. We'll fill the values for BO and OC, which we found in part A. However, this answer is wrong. We wrote BO as B, but we learned that direction matters in vectors, so BO will be the reverse of OB, which is negative B. Therefore, the correct answer will be BC equals A plus B. Next, we have to find AD, for which we need to know AC and CD. We know that AC equals 2B, but CD is unknown. However, we have been given this information, which we can use to find CD. Write them as fractions and make BD the subject. Now, it's pretty straightforward that BD is 1/3 of BC, therefore DC must be 2/3 of BC, because BD and DC are the two segments of the same line. Therefore, we can write the equation DC equals 2 upon 3 BC, then input the value of BC to find DC. Now we can find AD with this equation. Fill in the known values, but remember to change the sign because we need CD, not DC. Further solve the equation to get the final answer. AD equals 4B minus 2A upon 3. The next part asks us to find AE in terms of A, B, and N. We also have been given some information in terms of N. We'll write these ratios as fractions, then make OE the subject of the formula because it is the unknown value. Next, we can see that AE will be equal to AO plus OE. So we'll write this down and plug in the value for AO. Again, remember to change the sign because we are going in the opposite direction, and then plug in the value of OE that we just found. Finally, plug in the value of OB to get the final answer, AE equals BN minus A. This question is a bit tricky. We have been given the equation AD equals lambda AE. Don't get confused with lambda, it's just a constant, and can be given any name like x, y, etc. Then we are asked to find the value of n and lambda. Let's write down the given equation and plug in the value of AD that we found in the previous parts, followed by AE. Now, we have to solve this equation. It might seem impossible because there are more than one unknowns. However, this can be solved by taking A and B as common on both sides, then equate them. Let's see how this can be done. First, write the left side as two separate fractions to get A and B as their coefficients. Do the same on the right side by opening the brackets. To make things clearer, let's put brackets around the coefficients of a and b and highlight them with different colors. Put each equation side by side like this to compare them. If we cut out the commonalities and equate the corresponding coefficients, we can find two equations like this. We have already found lambda, so we need to find n. Simply plug in the value of lambda in the other equation to find n. The final answer is n equals 2 and lambda equals 2 upon 3. In the next part, we have to prove that OACE is a parallelogram, for which we need to prove that the opposite sides are equal in length. Starting with AC and OE. OE is unknown. In the last part, we found the equation OE equals OB times n. Plug in the values of n and OB to find OE, which gives the answer OE equals 2b. Therefore, we have proven that AC and OE are equal. Next, OA and EC, where EC is missing. By using the addition rule, we can say that EC equals EO plus OA plus AC. Write this down and fill in the values. Remember to flip the sign for OE, minus 2b plus a plus 2b. Minus 2b and 2b cancel out, leaving a. Therefore, OA and EC are proved to be equal. We have proved both pairs of opposite sides to be equal, which is enough to prove that this is a parallelogram. Next part involves the principle of similar triangles. OE is 2b, therefore BE will be B. Let's cut out other lines and leave the triangles we have to work on. The area of triangle ACD is given, which is 30 centimeters squared, and we have to find the area of triangle BDE. If we look at the triangles, we can see that these corresponding angles are equal, as the lines AC and BE are parallel. The center angles are also equal, as stated by the rule that says opposite angles around a point formed by two intersecting lines are equal. This information is enough to say that both triangles are similar, as stated by the similarity rule, angle, angle, angle. The formula for the area of similar triangles is this. A1 is unknown, A2 is 30, L1 is B, and L2 is 2b. B cancels out. Squaring gives 1 upon 4. Bring 30 over to the right side, which gives A1 equals 7.5. Therefore, the area of triangle BDE is 7.5 centimeters squared. This is it for this video. Let me know in the comments if you have any questions regarding this topic. Thanks for watching.